In today's video, we're going to look at the second part of the law of sines chapter. So as I said in the last video, in particular today we want to look at triangles when you are given two sides but not the angle that is between them. So if we draw out a quick triangle here, then you would have the three angles alpha, beta, gamma with sides A, B and C, and then you would be given any two sides of this triangle. So let's say that you were given A and B, and then one of the two angles that is not between those two sides. So we would not be given gamma, but we could be given either alpha or beta. Okay, so let's look at the possibilities that we can have here, and there is a few different things that you will come across depending on the triangle that you have. The three possibilities that you can have is where there are no possible triangles, so 0 possible triangles, and I'll tell you what to look for and how you will know that that is the case. You can have one possible triangle or two possible triangles. So we will look at the three different cases that we have here and what you expect to find for each case and how you know that there is 0, 1 or 2 possible triangles. Okay, and this is only for when we have the side-side angle triangles. So the first example is going to be one where there are no triangles possible, and I'll show you exactly what we are looking for. So if I draw this out, I am given the two sides 1 and 10, and I know that this angle here is 50 degrees. I don't know this angle here, I'll call it alpha, and I'll call this angle beta, and I don't know the side B. Okay, so I've got to solve this triangle, and I'm going to use the law of sines. So I know that sine of 50 degrees divided by the side opposite it, which is 1, is equal to sine of beta over B, which is equal to sine of alpha over 10. Okay. The one that you can solve for here is alpha. Okay, I don't know beta or B yet, so I can't really go ahead and use that fraction yet. What I'm going to do is solve for alpha. Once I've got alpha, that would enable me to find beta, and once I've got beta, then I can find B. Okay, so you kind of have to go through this systematically. So I know sine of 50 degrees over 1, well that's the same thing as saying sine of 50 degrees, if we're just dividing it by 1, is equal to sine of alpha over 10. So if I multiply through, I know I've got sine of alpha is equal to 10 sine 50. Now if I do sine inverse on my calculator of 10 sine 50, so you can go ahead and find that 10 sine 50 is 7.66. If I try to do sine inverse of 7.66, I'm going to come across a problem. Okay, you can type it into your calculator. That's what I would do in order to find alpha. In this case, I do sine inverse of 7.66 and see what the angle is that comes out. But you're going to come up with an error. Why is that? Well, this is telling us that sine of alpha is equal to 7.66. Remember that the range of sine is between -1 and 1. This is outside of the range of sine, so I know that it can't actually be possible, telling me that there are no triangles possible. So if you come across this, where you go ahead and you try and solve for a particular angle by doing sine inverse of the value that you have here, and you find that the value is outside of -1 to 1, then you know that there cannot possibly be an angle there, because you can't do sine inverse of a number greater than 1 or a number less than -1. So we know that we have no triangles possible because we come across a problem where we cannot solve. Okay, so that would be what you were looking for if there are no triangles possible. Okay, you'd go ahead and try and do sine inverse to solve for an angle, and it's not possible. What about if there is one triangle possible? Well, in these cases, you're going to be dealing with a triangle that has at least one angle that's 90 degrees or greater, just as a heads up. That's where we're going to find this one triangle possible type of problem. So let me go ahead again, and this time I've got one angle here that is 106 degrees. Then I've got, I'll call them beta and gamma, here and here. I know that this side is 4 and this side is 8, and I don't know this side. So if I go ahead again and use my law of sines in order to try and solve for this, I would get sine of 106 degrees divided by 8 is equal to sine of beta divided by the side opposite it, which is 4, which is equal to sine of gamma over c. So in this case, what I'm going to do is I'm going to solve for beta first, because I know that I can set these two fractions equal to one another, solve for beta. Once I have beta, I can go ahead and find gamma, because I know all of my angles should add up to 180. And once I have gamma, I can go ahead and find c. So kind of go through it in this order. Whenever you have these triangles, these side-side angle triangles, go ahead, find the angle on the fraction that has one piece of information in it. So we know that we've got the length of the side opposite beta, so I'm going to go ahead and find beta first, because I at least have one piece of information in this fraction. Once I have that, I'm going to solve for the other angle, and once I've solved for the other angle, I'll solve for the other side. Okay. So that's what we're going to go ahead and do here. So first, to solve for beta, I'll set these two fractions equal to one another, multiply both sides by 8, multiply both sides by 4. That's going to leave me with 4 sine 106 is equal to 8 sine beta. Divide both sides through by 8 and then type it into your calculator. So you'd have 4 sine 106 divided by 8. That would tell me that sine of beta, when you type it into your calculator, is going to be 0.4806. And then if you type into your calculator sine inverse of this value, now this value is between -1 and 1, so we know that we're going to get an angle back from this. Do sine inverse of that value on your calculator and you're going to get 28.73 degrees. Okay. How do I know that there is only one triangle possible here? Well, over here I've got a quick sketch of a unit circle, okay? If I find that my angle beta is 28.73 degrees, I know that that's in quadrant 1, so we'll draw roughly where that's going to be, okay? So this is 28.73 degrees. Okay. And I've just found out, if I go back a step, sine of that angle is 0.4806. That is the y-coordinate of the point on the unit circle for the terminal side. Okay, so the point where the terminal side hits that unit circle, it has a y-coordinate of 0.4806. However, it's not the only angle that has a y-coordinate of 0.4806. Remember, the sine of the angle is always the y-coordinate. If I dot out a line here, this angle that has a terminal side here, I'll draw the angle out here in blue, this angle here also has a y-coordinate. It has a negative x-coordinate compared to 28.73 degrees. So the cosine value for the angle is going to be negative here. But the sine of this particular angle over here is going to be the exact same because they're in line with one another. So the y-coordinate here is going to be the exact same. So they both have a y-coordinate of 0.4806. Question is, what is that angle? Okay. Well, we can kind of tell by symmetry. It's going to be 180 minus 28.73. Okay. That angle, if you work it out, is going to be 151.27 degrees. That's a huge angle. Okay. we know that beta cannot possibly equal this angle of 151.27 degrees because, there we go, we've already got an angle in our triangle of 106 degrees. 106 degrees plus 151.27 degrees is greater than 180. So I know that my only possibility for beta is going to be 28.73 degrees. It's the only angle small enough that has a sine value of 0.4806 to where I can actually fit it into my triangle. So that's where I know that there is only one triangle possible. When you get to this point, and this is just for side-side angle triangles, that's the only time I want you to check this for law of sines. When you get to this point, I want you to look at, okay, beta is whatever value it might be. Then I want you to figure out, okay, what's the other angle in my unit circle that also has a sine value of whatever it might be, in this case 0.4806. Once you've figured out what the angle is, see if that other angle will fit into your triangle. If it doesn't, you know that there's only one possibility. If it does, we've got to solve two different triangles here, okay? And there would be two possibilities. But in this case, we know that the only possibility for beta is the one that the calculator gives us. It's that original angle that's in quadrant 1 of 28.73 degrees. So then we can carry on and solve the rest of the triangle using that angle. So now that I know that beta is 28.73 degrees, I can solve for gamma. So gamma is going to be 180 minus 106 minus 28.73 degrees, because I know that all of these angles have to add to 180. So that tells me that gamma is 45.27. And then going back to my law of sines, now that I know that gamma is 45.27, I can go ahead and solve for C, okay? So I'm going to set this fraction here equal to this fraction here using gamma is 45.27. And if you go ahead and do that, I'll tell you what it is. You can go ahead and deal with the fraction. It's 5.91, okay? So just a quick recap of what we've done here. I've written out my law of sines. I've gone ahead and seen what that angle beta is, the angle that I can solve for where I've already got its opposite side. Once I've solved for beta, I've then looked to see if there is any other possibility for beta that would also fit inside my triangle. To do that, I've looked at what other angle gives me a sine value of 0.4806 that I have here. See if that angle fits into your triangle. If it does not, because you've already got another angle that's big enough to where if I add the two angles together, I'm going to get greater than 180, I know that that's not possible. So I, in this case, like here, only have one possibility, okay? Then you can go ahead, once you know that there's only one possible angle for beta, you go ahead and solve for the rest of the triangle. So you can solve that third angle because you have two of the angles already and you know that they have to add to 180. So I've gone ahead and solved for gamma. And once I have gamma, I can set these two fractions equal to one another and solve for that final side. So now we're going to look at the example where there are two possible triangles from the information that is given to us. So in this example, I've got this triangle here, and I know that one of my sides, we'll call it A, is 10.1. Another one of my sides is 7.3, and I know that the angle that is opposite the side of length 7.3 is 35.1 degrees. Okay. So at the moment, I don't know this angle. We'll call it alpha. I'll call this gamma, and we'll call this C. Okay. So I need to find alpha, gamma, and the side C. So let's go ahead and do the law of sines. So I know that sine of 35.1 degrees divided by 7.3 is going to equal sine of alpha over 10.1, which is going to equal sine of gamma over C. Okay. So I have all of my information in my first fraction. In my second fraction, I need to find alpha, and I don't know gamma or C in my third fraction. So let's go ahead and solve for alpha in this second fraction. We're going to use this first fraction and set them equal like we have here and go ahead and solve. So that tells me that sine of alpha will equal 10.1 times sine of 35.1 degrees divided by 7.3. And if you go ahead and figure that out, you should get 0.79556. So we know that at least one triangle is going to be possible here because sine of alpha is within the range -1 to 1. So we know that we've got a value for sine that's within the correct range, so I can go ahead and find sine inverse. So if you do sine inverse of this value in your calculator will give you that alpha is roughly 52.7 degrees. That's fine, and we know that that will definitely fit inside our triangle, and then we could go ahead and find gamma, and once we found gamma we can find C. But it turns out I'm going to call this alpha 1 because the other possible angle that has this same sine value of 0.79556 is going to be that one that if we do 180 minus the angle that we have found here is going to be another possible angle. So if I do 180 minus 52.7, I get 127.3 degrees. Okay. Does this fit in our triangle? Well, 127.3 plus 35.1 is less than 180. So this is also another possible angle that still has a sine value of 0.79556. So it's another possible angle that could fit in this triangle because it's not too big with the other angle that's given to where it's over 180 degrees total for our angles. So this is another possible angle that we could have, 127.3 degrees. Okay. So we're going to be solving two different triangles here. First thing I'm going to do is to solve the first triangle where I know that alpha 1 is going to be 52.7. So I know that if we go back to our drawing here, that bottom angle is 35.1. This angle here would be 52.7. I don't yet know my third angle, gamma. We'll call it gamma 1 for our first triangle. And then at the moment, I know I've got 10.1 down here, 7.3 here, and I don't know C. So this is triangle 1. And I still have to solve for gamma 1 and C1. My second possible triangle is where I have 35.1 degrees down here. I have 127.3 degrees up here. I need gamma 2 and I need C2. Okay, so there are two possible triangles. So now you go ahead and solve for gamma 1 and gamma 2 exactly the way that you normally would. You'll add your two angles that you've already got together and subtract it from 180 and that will give you gamma 1. So gamma 1 is going to equal 92.2 degrees. And gamma 2, again doing the same thing where I've added 35.1 to 127.3, subtract that from 180 to give me that third angle. That's going to be 17.6 degrees. Okay. And then we're going to go back to our law of sines and plug all this stuff in, plug in gamma 1 and gamma 2 into here, and then solve for each C value. Okay, so you're just going to rearrange those fractions exactly like we have previously, and you should find that for your values of C, you get that C1 is going to be 12.7, and C2 is going to equal 3.8. Okay. So once you've got these two different triangles, the rest of the problem falls out exactly like our previous problem with just one triangle that was possible. But it just means that when we looked at the possible angles that have this sine value down here, we found that there were two different angles that actually fit into that space in our triangle. So then you have to solve two separate triangles and you solve each one in exactly the same way that we have done previously.